Hi everyone, welcome back to Data Enthusiast Era. Today we are diving into GitLab CI/CD, not just what it is, but how you actually architect, deploy, and optimize real pipelines. If you are building DevOps systems for Node.js, Java, Python, or scaling across clouds, this one is absolutely for you. Here is the thing, the XYZ team is moving their on premise platform to the cloud. Their DevOps lead, Alice, is tasked with building CI CD from zero. The setup includes Docker, Kubernetes, and multiple languages, and the pain points hit hard. No version control, manual integration, slow tests, risky releases, and manual deployments everywhere. What this really means is the team needs a full DevOps foundation, version control, automated tests, Docker builds, registry pushes, Kubernetes deployments, and automated integrating testing. Without this, scaling across clouds is impossible. Before choosing GitLab, the team compared Jenkins, Travis, Circle CI, GitHub Actions, Spinnaker, Bamboo, the usual suspects. Everything looked greater on paper, but the moment they touched Jenkins, the overhead exploded. VMs, plugins, firewalls, multiple runtimes, Docker installs, cloud CLIs, vulnerability scanners, too much maintenance, too little delivery. Why Jenkins became a problem? Let's break it down. Jenkins is powerful, but for a small Node.js project, it became a full time operations job. Java, plugins, firewalls, Docker, Helm, CLIs for AWS and Azure, scanners like Trivi and KubeSec, all of it had to be installed, patched, and maintained. Every new tech stack added more chaos. The turning point. The team realized something obvious. They are spending more time babysitting CI CD than writing pipelines. They needed a clean, integrated CI system the whole team could use, not just experts. Why GitLab CI CD 1? GitLab CI CD changed everything. GitLab is a version control tool and it merge requests, pipelines, registries, security scans, Kubernetes deployments all under one roof. With built-in runners, no servers to maintain, and clean YAML files, the team could focus on shipping features instead of maintaining tools. CI versus CD. Before we build anything, let's anchor the basics. CI handles automated tests and validation for every commit. CD handles automated deployments to staging with a manual approval step. Continuous deployment goes one step further and pushes straight to production without human intervention. Simple idea, massive effect. Typical Git workflow. This is the heartbeat of modern systems, modern teams. Developers branch off, main, commit, push, open merge requests, run automated tests, get reviews, and merge back once everything passes. You protect the main branch, enforces CI checks, and keep releases clean and predictable. Problems without CI/CD. Without CI/CD, teams hit the same walls. No guaranteed testing, constant manual errors, slow feedback loops, and merges that feel like walking into a minefield. Continuous integration in action. Now imagine this: developer A opens a merge request for feature A. CI runs unit tests, dependency checks, security scans, builds artifacts, and pushes results. Developer B does the same with feature B. CI ensures both features work independently and together before landing in main. This is how teams keep the main branch healthy. Delivery versus deployment. In continuous delivery, you deploy automatically to staging but wait for a manual approval for production. In continuous deployment, everything, including prod, is fully automated. The catch: your test suite has to be rock solid. Introducing GitLab CI/CD. GitLab CI/CD works right inside your repo. You write your pipeline in a single YAML file, and GitLab handles execution, logging, security, and environment setup. This tight integration is what makes GitLab shine. How GitLab jobs run. Here is where GitLab simplifies life. Pipeline job run on GitLab runners. These can be SaaS runners or your own self managed runners. SaaS runners require zero setup. GitLab spins up fresh machines, executes the job, catches dependencies, and tear down the environment automatically. SAS runner types. You get Linux, Windows, Mac OS, and GPU runners out of the box. Linux for almost everything, Windows for .NET, and Mac OS for Apple builds, GPU for ML workloads. You literally just reference the tag in your pipeline and you are done. Let's walk through a simple sample pipeline. We define a workflow that runs only on main. Then a test job runs parallel across Linux, Windows, and macOS runners using matrix builds. GitLab spins up three environments, install dependencies, tests, and report results. Once the pipeline runs, you can inspect logs, download artifacts, check test coverage, and review failures all from the GitLab UI. It is simple, visual, and consistent. Now, let's get into some hands on. Let's open GitLab. Signing into GitLab is straightforward. Use email, Google, GitHub, Bitbucket, or Salesforce, whichever. Once you are in, you will see your personal namespace, group namespaces, and all your projects. So here is the one. I'm selecting Google as of now. So they have sent a verification code. Verification is successful. You'll be directed to your account in a minute. Role DevOps engineer. I'm signing up for GitLab because I want to learn the basics of Git. You can select whichever you'd like to. Just me continue. So if there is an existing project, you can select that and you can search for that project and you can join that. But here we want to create a new project. So I have selected that. Click on continue. So the group name is this and the project is this. We can try that. And there are some existing templates as well. You can select any of these if you want to. As of now, I am keeping this optional as it is and click on create project. So this is the GitLab project and here you can see build, jobs, pipeline editor and multiple other options. So I'm simply going to build pipeline editor and here you can see this is the main branch. So configure a pipeline to automate your builds, tests and deployments. Create a .gitlab-ci.yml file in your repository to configure and run your first pipeline. Just clicking on configure pipeline and here is the thing. So here is the thing, they have given a default one. Even you can just click on commit changes. This will do the build. Checking pipeline status. If you click on pipelines, pipeline got failed. So it is saying before you can run pipelines, you need to verify your account. Click on verify my account. So it is asking the phone number. So here it is saying YAML is invalid. So I'll just try to edit that again, removing everything. So this is dot gitlab-ci.yml. Let's start with workflow, name, I'm just giving that workflow name as this. Let's add rules. If so, I'm making sure that it runs only on the main branch. Done. Now we can add stages. I'm giving it a test and I'm adding another job, unit test job. Okay, now we have added this. Now let's add stage. Once I read the code, I'll explain it. So this is Linux. This is Windows. So this is Node 17 Alpine version. So if there are any prerequisites, we have to give. All right. So here, if you see parallel matrix format, so this uses a list of maps. Each map sets the operating system variable to an array of values. So the GitLab spans on one job per OS. And here if you see rules value coded safer for YAML parsing and ensures branch check behaves as intended. So here we have added stages, set the stage as test here. This explicit stages make pipelines easier to extend later. So the before script npm ci is faster deterministic for CI environments versus npm install. Artifacts keep coverage output available after the job, helpful for merge request review. The tags operating system instructs GitLab to pick the runners. This one. To pick the runners tagged per tagged per operating system. Ensure your runners are tagged exactly with SAAS Linux small AMD 64 shared windows and SAS macOS medium M1. And if there are any tags which are matching our runners, we can change it. So if your GitLab SAS runners are used, you may not need custom tags. Remove the tags to let shared runner pick up jobs. Consider upgrading to Node 18 for long-term support. If runners don't accept the variable in the tags, replace tags with the static list or provide matching runners. Let's give it a try. Again, it got failed. So there is an invalid error. So we have to check this. Workflow rules, rule if invalid expression, some syntax issue here. So here I missed this. Let's try now. Okay, the pipeline syntax is correct. And if you go to the pipelines, you'll see currently it is running. And if you see the job name which we have given, unit test job, and here if you see there are 3 tags. So if you see no matching runner available, hence it got failed. The other 2 are still running. This is pending and this is also pending. We are checking here. The job has not yet started because one of the problems, there are no active runners, no runners for the protected branch. So if you go to the CI settings, if you click on the runners, you will see these are some of the existing runners. And if we remove that, let's try this. The pipeline editor, here if we remove the tags, so now what I did is, as the ones which are there are no matching runners, what I did is I just changed to Linux, Windows and Mac OS, and I have removed the tag session so that here it will check for whatever the Linux operating systems are present, Windows whichever are present, it will match and it will automatically build that. Let's try committing the changes. If you go to the jobs, so this is running, this is Mac OS, this is Windows, this is Linux. If you go to the pipelines, all the three got failed again. Let's try to fix it. This is a genuine error because there are no files to upload, right? So this file is missing, hence it is unable to do a clean install, and there are no matching files as well. Now it worked. I just changed it to a very simple pipeline. Just added one stage, test the test job, and added that stage, and the script is just it will print GitLab-ci is working. So the job is successful now. It I'll just collapse this so it will be easy for us to see the steps. So running on this particular GitLab runner, and it ran on SAS Linux small AMD 64, and then it prepared the Docker mission executor using the default image, using the Docker executor with this image, and then using the default image for the policy, and then it prepared the environment, and it is getting source from the Git repository. It initialized the Git repo on that machine, and then it executed the script echo gitlab-ci is working, and you can see it was printed and the job is succeeded. Clean up project directory files based variables, there is nothing, hence it didn't execute anything, and then the job got executed. This is how we build the we do the CI in GitLab CI part. And there are some usage CI quotas also. So, what is understanding personal versus group namespace? A GitLab project is where your code lives and everything else issues, boards, pipelines, reviews, deployments. Namespaces organize projects into personal and group folders so that you can manage access cleanly. So if you are using GitLab SAS, you get 400 compute units per month on a trial account. Usage depends on how long your job runs and which runner you use. Linux is cheaper, GPU is expensive, and it makes sense. Cost factor, if you want to break down, every runner type has a cost factor. A Linux small runner might cost 1x, while Mac OS or GPU can be higher. The key is to keep pipelines fast and efficient. So here is the takeaway. GitLab CI/CD gives you modern pipelines without the hassle of maintaining infrastructure. You get version control, automation, Docker builds, security scans, Kubernetes deployments, and smooth delivery all in one platform. If you are building DevOps systems at scale, GitLab just fits in. And that's how Alice team moved from chaos to clean automated delivery. Thanks for watching. If you have any queries, please comment in the comment section, and I'll try to make some more videos with the hands-on on GitLab CI/CD. Thanks for watching.